So Ethan Cho made a video on 6x6 parity last two edges, and I thought it was pretty cool. There's some stuff I had never seen before, but I also thought there's some things I can add. The first thing I wanted to talk about is for a couple of the cases, Ethan shows that you can flip one of the edges to set up to another case. So like for this one, you could flip this edge, set up to this case. And so I wanted to show you that you can achieve the same thing with less moves. So you can put this edge in the back and do an F move, then do the AUG, and then undo the F move at the end. So that works for any case where you want to flip one of the edges. So for example, this one, you could put this edge in the back and F move and have this case. But for this case specifically, I also think it's valid to just slice of slice, solve one of the edges, and then triple parity, avoid. Okay, next thing is for this case, in Ethan's video, he shows you can do slice of slice and triple parity avoidance, which I think is valid, but there's also an AUG for it. So it is similar to this case on 5x5, right? You can see how it looks similar. So on 5x5, you would do this AUG. So on 6x6, you can do something similar, but with some slice moves. So it looks like this. Slice, slice, slice. So this is the mirror of that case. So on 5x5, it's like this one. So this AUG. So on 6x6, it's like this. Next thing I wanted to go over are these cases where it's not really clear what's going on. So in Ethan's video, he shows that you can solve the inner wings like a 4x4. So in this case, you would have to do a flip and then slice of slice, and then solve the outer wings with whatever case it ends up being. So in this case, it would be a parity L2E. Maybe this is fine, but I like to take a different approach where I just focus on solving one edge, and then the other edge will end up being either solved or have parity. In this case, it will have parity, but I don't know if I would usually predict that. And so the idea is, like, let's say we're focusing on the orange edge for now. So if I want to like solve the orange edge here, so like leave these pieces where they are and insert these pieces here and here, then notice how one of the wings is already set up for a slice of slice. So this one, the outer wing, is already set up for a slice of slice. So you could slice here, flip, and it would end up here. And this wing is not set up for a slice of slice. So it would have to flip and then slice of slice to here. But we can use the flip from this slice of slice to flip this one to set it up for a slice of slice. Does it make sense? So as long as these two flip together, then whichever one is not set up for the slice of slice will end up being set up for its slice of slice. So for this one, we slice here, solve the outer wing, and then solve the inner wing like that. Yep. So for this case, it's a similar idea. Again, we'll focus on the orange edge. So in this case, the inner wing is set up for a slice of slice and the outer wing is not. So we have to do this slice to make sure that this one gets set up for the other slice of slice. And do that. For another example, this case, so again, we'll focus on orange. So this time we'll solve the outer wing first because it's set up for a slice of slice and the inner wing is not. So do that one and then cancel like that. Yeah. For this case, Ethan shows a really cool AUG that I've never seen before, but I also think it's completely valid to just slice of slice to solve the orange edge and then leave the green one with parity. Like, I think that's fine. And if you had like this, then you just flip and then slice of slice. Yeah.